Today's goal is to evaluate reciprocal trig functions of key angles. Yesterday, we mentioned that there are 6 trigonometric functions, all of which use an angle measure as input, or x value, and they produce a ratio of side lengths as an output, or its y value. Yesterday, we focused on the trig functions sine, cosine, and tangent. Today, we introduce the reciprocal trig functions, which are cosecant, secant, and cotangent, abbreviated in this table below. We call these the reciprocal trigonometric functions because the cosecant of an angle theta is exactly the same as the reciprocal of the sine of its angle. And secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. Oops, I want to make sure that's clear. The cotangent of theta is the reciprocal of the tangent of theta. Let's see how these look in action. Example 1, evaluate all 6 trigonometric functions of the angle A. So let's start in order. Sine of A is opposite over SOHCAHTOA. Sine of A is opposite over hypotenuse. 3 is the side across from or not touching A, so this would be 3/5. The cosine of A is the adjacent 4 over the hypotenuse 5, and the tangent of A is the opposite 3 over the adjacent 4. Now you can find the cosecant of A in a couple of ways. You can say, okay, I know that this will be the same as 1 over the sine of A, which will be 1 times 5 over 3, which is 5 over 3. You could have also just simply taken the sine of A and flipped it about. So here's the shortcut. The secant of A is the reciprocal of cosine of A. So if the cosine of A is 4/5, the secant of A will just be 5/4. And the cotangent of A is the reciprocal of the tangent of A. So if tangent of A is 3/4, cotangent of A is 4/3. We're just flipping these fractions upside down. Example 2, evaluate all 6 trigonometric functions of 5 pi over 3. Well, we know 5 pi over 3 is, 1 pi over 3, 2, 3, 4, 5. It would be in the 4th quadrant, closer to the y-axis. So its coordinate pair would be positive 1/2. You're moving to the right a short distance. Negative root 3 over 2. You're moving down a further distance. So sine of 5 pi over 3, that angle is our input, is just the y value, negative root 3 over 2, because that's the ratio of, if you drew a reference triangle, here's your angle, that's the ratio of the opposite hypotenuse. Of course, the hypotenuse is length 1, right? The cosine of 5 pi over 3 is just its x value, and in this case, that would be 1/2. And the tangent of 5 pi over 3 is the sine of 5 pi over 3 divided by the cosine of 5 pi over 3. So that's negative root 3 over 2 times 2 over 1, which gives us just negative square root of 3. Okay. The other trig functions, I like to write them out in order. Cosecant I write next because it's the reciprocal of sine. So the cosecant of 5 pi over 3 is just negative 2 over square root of 3. I'm taking this fraction and I'm flipping it upside down. Then I just have to make sure I don't leave it with a square root in the denominator. So I rationalize the denominator. Secant of 5 pi over 3 is even easier. I'm going to take this fraction cosine of 5 pi over 3 and flip it around. 2 over 1 is, of course, just 2. And the cotangent of 5 pi over 3, I like to look at this right here and just flip this fraction around. You can flip it at any stage, of course. So you'd have 1/2 over negative root 3 over 2 gives you 1/2 times 2 over negative root 3, which gives you negative 1 over square root of 3. Just rationalize that denominator so you don't leave it with a square root in the denominator. And you get negative root 3 over 3. All right, example 3, evaluate all 6 trig functions of pi. Again, let's draw it. Here's my angle pi. Let's label its coordinate pair, and let's get to work. The sine of pi is just its y value. Cosine of pi is just its x value. Tangent of pi is sine over cosine, so 0 over negative 1 gives me 0. Now this gets a little bit tricky. Cosecant of pi. I'm going to take this fraction and flip it upside down, except of course it doesn't look like a fraction. Well, you can always use a denominator of 1. 0 is the same thing as 0 divided by 1. So when I flip it upside down, 1 divided by 0, of course, is undefined. You can't divide by 0. What would that even mean? Okay, secant of pi, we're going to take this fraction and make it into a fraction and then flip it upside down. 1 divided by -1 is of course just -1. And then cotangent of pi, again, make anything into a fraction by putting it over 1. But when you try to divide by 0, you get a fraction that is undefined. One more example for us today. We're going to evaluate two expressions, the secant of 7 pi over 6 and the cotangent of 3 pi over 4. Now secant, that's the reciprocal, sine, cosine, tangent, cosecant, secant, cotangent. This is the reciprocal of the cosine of 7 pi over 6. So I just need to know what the cosine of 7 pi over 6 is. This would be the angle in the third quadrant. Let me really exaggerate for you. It'll be closer to the x-axis. So its coordinate pair, you're going to the left a long distance and then going down a short distance. Cosine of 7 pi over 6 is its x value. This would be -√3 over 2. Therefore, the secant of 7 pi over 6 would be 2 over -√3, which will rationalize the denominator. You get -2√3 over 3. And the cotangent of 3 pi over 4, well, that would be the reciprocal of tangent. So let's find out the tangent first. 3 pi over 4, that would be in the second quadrant, going equal parts left and up. So x and y values have the same magnitude, but different signs. Left is negative, up is positive. So the tangent of 3 pi over 4 would be sine over cosine. So y over x, which is √2 over 2 times 2 over -√2. These cancel, you're just left with -1. So the cotangent of 3 pi over 4, we need to make this into a fraction, flip it upside down, and you also get -1.